Combining like terms. So, like terms in math mean something very specific. Let me show you some examples of like terms. 3, I'm going to use a plus symbol, and 2. These are like terms. Okay? 5x and 12x. These are also like terms. Y and 2y. These are also like terms. Z, 5z, and 8z. These are also like terms. So what is it that makes these like terms, these like terms, these like terms, and these like terms? What is similar about 3 and 2? Yeah.
The pot.
Okay, so right now I'm dealing only with positive numbers.
They both add up to 6.
It's a great observation. And these could be negative and they would still be like terms. Okay. So it's not going to have anything to do with the pluses or negatives. It's a brilliant observation. Right? So maybe I should give you one more example. 4 and negative 3 and negative 11. These are also all like terms. Yeah.
Is it because they're all added?
They're all adding?
No.
I did use the plus symbol here. I'm kind of just trying to list the terms, but we don't usually see them with commas. So that's why I chose to use a plus symbol. They would be like terms if we had a subtraction as well. So if I had something like 5x minus 3x minus x. These are also like terms. Again, really good observation. That was just my fault for not writing anything with negatives or with minuses. So what is it that makes these two like terms? It also makes these two like terms. I'll give you a hint. This is not a like term with this. These are not considered like terms. So what's different between 3 and 5x? Or between 2 and 2y?
I think I get it.
Yeah.
So, 3 and 2, they're the same because they don't have an x, and then 5x plus 12x, and then y, 2y.
Good. Yeah, so these don't have any x's or y's. There's no variables here, right? These both have x. That's what makes them like terms. These both have y. Now, there's a kind of a weird exception to this rule that I'm going to show you guys over here. If I had something like 5x and 7x squared, these are not like terms. They both have x's, but the x's have different exponents. Okay? So these are not like terms.
Because that one has x.
Because this one has x squared and this one only has x. So like terms are terms with the same variable. Y and 2y are like terms. Let's do some practice. Are these like terms? Are those like terms?
Yes.
Yes. Are these like terms? Are
Yes.
these like terms? How about this?
No.
Are these like terms?
Yes.
No.
Yes.
Well, yeah.
Yes.
Yeah. They have the same variable. What is the variable? No variable. Right? There is no variable. So any constants, anything that are numbers, we call these constants in algebra. It just means there's no variable attached to it. How about this? Are these like terms?
No.
Why not?
They're not the same. There's a variable.
This
involved.
one has an x, this one does not.
Yeah.
Oh, it's like playing a matching game.
It is kind of like playing a matching game.
I like that game.
So let's talk about how we use this in math. The cool thing about like terms is that they can be combined. So if I have 5 x's and another 12 x's, I can combine these together into one term. How many x's do I have if I have 5 x's and 12 x's?
17.
Yeah, I have a total of 17 x's. So 5x plus 12x becomes 17x. Like terms combine together by adding, not by multiplying. So if I have like 3 and 10, what does that become? 3 and 10.
13.
13.
Wait.
What if I have 12x and 11x? What does that become? 12x and 11x. I can combine those two like terms to make.
I'm not talking all the time. 23.
Yeah, 12 plus 11 is 23x. Very good. How about this? Watch out. This is a trick question. What can I combine those two? They're not like terms, so I can't combine them together. Right? There's no way to combine 5x and 10. If you think of x as like an object, this says like 5 oranges plus 10. How many oranges do I have?
5.
5. And then I have 10 of something else, right? But I don't know what that something else is.
You can't.
It's the same thing if I had 2 different variables. Like if I have 2 oranges and 3 apples,
You can't do
I
that.
can't combine those, right? So think of your x as like oranges and your y as apples. Or you could think of your x as diamonds and your y as silver. Pomegranates, exactly. And it might help you to think about why we can't combine these or these.
So you can't combine
Alright.
an x with a y because they're two totally different variables.
Right. We can't combine because they're totally different variables. Now, this gets a little bit more complicated because I can combine something in this expression. First of all, why is this an expression? What does an expression mean?
An expression is something without a equal sign.
Yeah, good. It's a series of terms without an equal sign. That's an expression. So there's no equal sign. We're not going to be solving it because there's no equal sign. But we can simplify it. And how do I simplify this? I combine like terms.
So you do
The
7.
first thing we have to do here is identify what are our like terms. And we're going to circle them. So what are our like terms?
2 and 7.
2 and 7
2
or?
x's.
Good. 2x
And
and
7.
7x.
Oh, and you
So
circle
those
them.
two can be combined.
And then you subtract.
Then I have a 3, which I'm going to put in a box to show that it's a little bit different. It's not a circle because it doesn't have an x. So 2x and 7x combined together make what?
9x.
Exactly. 9x. The 3 doesn't combine with anything, so I leave it off to the side. So this expression simplifies to this.
9x plus 3.
So you can't subtract stuff from
You
can't subtract
totally
things
can
from-
subtract. We'll get into subtraction in a
from
minute.
expression.
Right, yeah, I can't manipulate my expression like I can with an equation. That's a good, right, I can't like add 3x to both sides.
Yeah.
Because there's not both sides, there's only one side. This is like one side of an equal sign. Okay, so 9x plus 3. Nice. What if I had this? Something like 15x plus 7 minus 7x plus 11 minus 2. Suddenly these are getting a little bit more complicated. But if we use this strategy, it's really going to help
We
us.
can do it.
What are all of the x terms? Just name them, and I'll circle them. So starting with 15x, what's the next x term? Looking at this expression,
It's 7x.
what's the other thing up here that has an x? Okay, good. You've identified it. And I want you to look at the whole thing. Because in an expression like this, the negative has to travel with the number that it's connected to. So my x term is not 7x. It's minus 7x. Do you guys see what I'm saying? I have to connect the minus to this term. My x term is minus 7x.
Wouldn't it be negative 7x?
You could think of it as negative 7x if you wanted to. So we could think of it as plus a negative 7x, if that helps you. Or you could just think of it as minus 7x. Okay? What are my constant terms? I'm going to put them in boxes. I have 7. What's the next one? 11. Is it 2?
No, it's minus.
Minus 2. Or, like Jake said, negative 2. Okay, so let's deal with the x's. I have 15x minus 7x. What does that leave me with? If I combine those two like terms. What does that become?
8x.
8x. And then I have 7, 11, minus 2. What does that become? I have to combine 3 terms. So I'm going to think 7 plus 11 is
7.
18.
18. Minus 2 is
17. 16.
16. So we're going to say plus 16. And that's it. That's all there is to it. Okay, all we're doing is combining like terms in an expression. So first we have to identify them, then we have to combine them together. Alright, let's try one that doesn't work out quite as pretty as these have.
Well, they look cool. They don't look pretty. Magical.
Okay. Make sure that all showed up. Okay.
Is it done?
So we've got negative 3x plus 12 minus 20 plus 1 minus 2x plus x. Let's circle all the terms that have x's in them, remembering to include the minus signs in our circles. Yeah.
Minus 3x.
Uh-huh.
Minus 2x.
Uh-huh.
And then x.
Yeah, x
Plus
or
2x.
we could say x or plus x, whichever one you want to do. So for some people it might be helpful to circle the plus. If that's helpful for you, go ahead and do it. Okay, let's put in boxes all the terms that don't have x's. So what's my first term with no x?
12.
I'm going to include the plus sign instead. Plus 12, what's another one?
Minus 20.
Minus 20, what's another one?
Plus 1.
Plus 1. Okay. I'm going to rewrite these. So I have minus 3x, and then I'm going to look for the next circle. So over here,
Minus 2x.
minus 2x, and then the last circle,
Plus
plus x. So what happens if I take minus 3x, subtract 2 more x's?
1x.
Minus 3, and I subtract 2 more. So I owe 3 oranges, and then someone takes away 2 more oranges from me.
You're 5.
Now I owe 5 oranges,
So 5x.
Negative 5.
plus 1x,
Negative
negative
4x.
4x.
Yep.
Right? 2 large or 2 negative numbers are going to combine to be a larger negative number. Negative 3 and negative 2 are going to make negative 5. Alright, now I have 12 minus 20 plus 1. What is 12 minus 20? Is that going to give me a positive or negative result? Negative, because 20 is the larger number and it's negative. So 12 minus 20 is negative
8.
18.
Negative 8 plus 1 is what?
9, negative 9.
Negative 9.
Negative 8 plus 1 is
No,
negative
it's
9?
9.
Negative 7.
Negative 7, right? So I have negative 8 here.
Jacob, stop it.
Plus 1 is negative 7. Alright? Negative 4x minus 7 is my final answer. So I combined all my constant terms and I combined all my x terms. Alright, one more level of complexity. What if I had something like this? What's different about that? Yeah.
The parentheses, like
The parentheses. Yeah, these, right? The parentheses. How can I get rid of them? Because they're kind of in the way. I want to get this x, right? So that I can combine it with this 7x. But I can't just take it out of the parentheses. So what is something we learned? What's a property we learned that would allow me to get rid of the parentheses here?
3 times x.
Yeah. I'm going to take this 3 and multiply it times the x. And what else? I'm going to multiply it times the 2. Distributive property. So if I have a distributive property type of problem, I have to do that first, right? I have to deal with these parentheses before I start combining like terms. So 3 times x is 3x. 3 times 2 is 6. Plus 7x minus 8. The 3 isn't going to touch these things because they're outside of the parentheses. Right? They're not inside the parentheses. They're way over here. Now I have no parentheses in my way, so I can circle all my x terms and put in boxes my constant terms. Okay. 3x and 7x make 3x plus 7x. It's going to give me
10x.
And then 6 minus 8
Negative 4.
plus
Negative 5.
negative 2. Or minus 2, right? So I have 10x minus 2. The key here was we did distributive property first. In your notes, you probably want to make a note to yourself. Something like, do the distributive property before combining like terms. Do the distributive property before combining like terms. You guys have questions about this?
Nope.
Nada? All right. Let's practice.